Hello, welcome back. In this calculus video, I'm going to be going over a related rates problem. I recommend pausing the video first and trying the problem yourself before seeing me solve it. Without wasting any time, let's get into it. So question 4 says, the spherical snowball is melting in such a way that it maintains its shape. The snowball is decreasing in volume at a constant rate of 8 cubic centimeters per hour. At what rate in centimeters per hour is the radius of the snowball decreasing at the instant when the radius is 10 centimeters? And we're also given the volume of a sphere of radius r is v equals 4/3 pi r cubed. So first, let's just rewrite this formula. So v equals 4/3 pi r cubed. And it says, and it's asking us for what rate is the radius of the snowball decreasing at the instant when the radius is 10 centimeters. Okay, so first, let's just interpret and understand what the problem has given us and is saying. So the snowball is the second sentence says the snowball is decreasing in volume at a constant rate of 8 cubic centimeters per hour. So in calculus notation, the way to represent that would be dv dt equals 8 negative 8 centimeters cubed per hour. And let me just explain this. Let me explain the dv dt notation first. So the dv first calculus notation, if you don't fully understand it, it might just look like foreign language to you. So it's important to understand it. Let's just think back to geometry. So ignoring everything I've said so far, if I were just to say if you just saw in a problem that the volume is equal to 500 centimeters cubed, right? This is a fixed quantity. That means like the volume of this, let's say a sphere, it's 500 centimeters cubed. That's a fixed quantity, and the sphere is always going to be at that much volume. Now let's go back to this problem. In this problem, that's not the case because it says the snowball is decreasing in volume at a constant rate of 8 cubic centimeters per hour. Because this means the volume is changing as time passes by. And that's exactly where this notation dv over dt comes in. So in calculus, whenever you see a d over a d, just think the change in one thing over the change in another. The dv on the top means the change in volume, and the dt on the bottom means with respect to time. So the change in volume with respect to time. So that's all that represents. And now the change in volume with respect to time is negative 8 cubic centimeters per hour. And it's negative because it says the snowball is decreasing in volume, which implies that the rate is negative. Okay, now let's look at the next sentence. At what rate in centimeters per hour is the radius of the snowball decreasing at the instant when the radius is 10 centimeters? Oh, sorry. Earlier, this represents the rate. dv dt represents the rate. So now let's go back to this sentence. At what rate? So that means we're going to have to use this notation again. And it says, is the radius of the snowball decreasing at the instant when the radius is 10 centimeters? So it's basically asking how fast is the radius changing as time passes on. So that means it's asking for the change in radius over with respect to time, dr dt, and that's what we're solving for, question mark. And we're given that the radius is 10 centimeters. Okay. Now, let's take the derivative of this formula so we can use these given rates, given rate and the radius equals 10 centimeters to solve for this rate. So let's take the derivative of the left side first. 1 times dv dt. And let me explain why. So I know a lot of people might say that if I take the, let's say if I ask you guys to take the derivative of something like x, right? You would just say the answer is 1. And that is right. But that would be when you're taking the derivative of x with respect to x. These two are the same variable. Oh, 1 second. These two are the same variable. That's why it's 1. But here, that's not the case, as you're taking it with respect to time. So that's why where the dv dt comes from. Now let's go on to the right side. Let's move on to the right side. It would be, if you want to take the derivative of the right side, you would do the power rule. You would do 4/3 times 3, which is 4. Pi is just a constant, so you do nothing with it. R is the variable, so you do r squared, because for the power rule, you multiply the exponent by the constant, and then you subtract 1 from the exponent. And again here, it's times dr dt, because you're taking the derivative with respect to time. If this was like r, if it was like d over dr, then you wouldn't need to worry about this. There would be no d over dr if it was the same variable. But since you're taking it with respect to time, which is a different variable from r, you need to have it here. Let me move this down. So now, that was weird. Okay. Now you have to just plug in the given known rate and r equals 10 to solve for dr dt. So 1 times -8 equals 4 pi 10 squared times dr dt. So you get -8 equals 4 pi times 100 times dr dt, which simplifies to -8 400 pi times dr dt. And since we're solving for dr dt, divide by 400 pi. That simplifies to -1 over 50. You get -1 over 50 pi equals dr dt. And that matches answer choice A. And I'll explain why the negative is not there. Because it asks at what rate in centimeters per hour is the radius of the snowball decreasing. Since it already says decreasing, that means it's just asking us like for the magnitude, just the number. It's not asking us about the sign, because if the radius of the snowball is decreasing, that already implies that the rate is negative. So that's why there's no negative sign in any of these answer choices. I hope that makes sense, and thanks for watching.